We're going to look at motion under gravity today. So you know what motion is all about, which is when a body moves from one point to another. We say this body has undergone motion, which means when the body moves from point A to point B, we say this body has undergone motion for it to have moved from one place to another. Okay, so that's what motion, the basic definition of motion. So we have different types of motion, but we're not going to discuss this in detail today. We'll be taking it part by part. We're going to look at a motion of an object on a horizontal plane, okay, and that of an object also on a vertical plane with the help of what? Gravity. We say the action of gravity has this when it is in a vertical plane, okay. So you know that a body or a motion of a body when on a horizontal plane can be a quite complex because it's always on a two-dimensional places. So let's say we have a body on the horizontal plane. This motion, most of the motions takes place on this horizontal plane. We have an example of this two-dimensional plane as when a footballer is dribbling his opponent. So we say it is two-dimensional. You know, it's quite complex. All right. So another example there is when a hockey player, all right, so is chasing a ball. We will say it's also what? On a two-dimensional place. So, and you know, this always takes place on a horizontal plane. Okay. So when we are discussing that of a vertical plane, it's with the help of uh, gravity that it will now occur. So now we're going to look at a motion of a vertical place as when a body is thrown upward. Let's take an example. A stone is thrown upward and this stone moves like this. So at a point it now comes down. So we say that this one is on a vertical plane because it goes upward vertically. So let me digest this a little bit so you understand how the action of gravity affects this. Let's say body, let's say I'm the person standing on this. This is a horizontal plane. Let's say this is me standing here, all right? So I threw a stone upward. So this stone goes upwards. This is my hand throwing a stone. This stone goes upward as it's going because immediately you throw the stone, it goes very faster, all right? Because of the force that you use to throw the stone upward. So it goes faster, and at a point, the stone started to lose the strength, which is the force that you use to throw it, and it becomes very slow. All right. So at this particular point, the force that you use to throw it is very high, and it reaches a point where it becomes what? Low. All right. So now it reaches a point as well where it is not stationary. At this point, the stone loses its strength. There's no particular strength for it to go further or even fall down again. All right. So we say this particular point that it is what? A stationary motion because there's no force that will help you to go upward again. So I will still explain more what all this low and high do I've explained, but I will explain more. So at this particular point, it now starts to what? Fall. All right? Start to fall until it hits the place or the ground where it was thrown from. So now, at this particular point, we say it is stationary. Then there is a force of gravity that is pulling the stone downward. because at this particular point, the force of gravity was acting on it. Force of gravity acts from top to down, all right? It acts downward, all right? That is how force of gravity acts. So, and this stone was thrown upward, and it means that the direction of the stone was opposite that of the what? Force of gravity. And why it was moving faster at this particular point was because we use a force to throw it, and strength the force that you use to throw it, your own force which is used to throw it, was greater than that of what? Gravity. And that is why it was moving faster at this particular point. All right. So at this point, the force of gravity, their own force started to be very low. All right. The force of gravity was not the same as, like, the force of gravity at this particular point was was somehow or somewhat greater than that of the force that used to throw it, because as it goes up, the strength was reducing. So the force of gravity continued to act on the stone, pulling it downward, which is the direction. All right, the stone, this is the stone, and this is the gravitational force. So it continued to act as it was going. It was pulling it, so the strength was reducing. It was pulling it, the strength was reducing. It was pulling it, and it reduced to a point that this particular point, there was no force again for it to go upward. So it was stationary, because the force of gravity has reduced all the strength that you gave the stone when you threw it upward. So that's why at this point it became stationary. It was not moving upward, it was not moving downward. And at this point, the force of gravity continued to act on it again. Then it started falling downward. And when it was falling downward with a high speed. Why? Is because there was no force acting or opposing its direction again. The reason is this: when it was falling downwards here, remember the force of gravity acts downwards, all right, and the stone was also falling downward. So this is gravitational force acting downward, and the stone, when it has reached its stationary point, it was also what? Acting what? Downward. And that's why it was moving faster. So this type of motion is what we call projectile motion. Projectile motion, or we call it ballistic missile. Projectile motion. Or we call it what? Ballistic missile. Ballistic what? Missile. Alright? So that's what projectile. We are going to discuss projectile motion fully. All right. So just I want to give you the introductory part of what motion under gravity is all about. Okay. So this now takes us to, okay, let's give you an example of projectile motion. A projectile motion, the example is a ball or a stone that is thrown upward, like I gave you an example here, is a projectile motion. And also, when you release an object from a window, it forms this curve, which is also what? A projectile motion. A bullet that is released from a gun is also known as what? A projectile motion. It undergoes this curve too. All right. So these are the examples of projectile motion. There are also numerous examples, but with this, I believe you also be able to give other examples of projectile motion. All right. So we're going to look at acceleration of free fall due to gravity. Acceleration of free fall due to gravity. So You know, an object without a motive power on its own will be able to move. Why? Is because of the action of gravity. Like I explained earlier, with the action of gravity, it will be what? Able to move. But this can happen when it's released into space. All right. So this object can move around, can also go upwards when it's released into what? Space. So that is with the action of what? Gravity. So if acceleration of free fall due to gravity, I'll give you an example. Okay. So a free fall, you may be asking yourself, what is a free fall? Though you already know what when something is free. That is when something is falling freely from the space. When something is falling freely from the top to the ground, that is what we say is free fall. And this is the action of gravity. Without gravity, it's not going to fall. And it's in line with what I explained to you earlier from this motion under gravity. Okay, acceleration of free fall due to gravity. Let's take an example because we'll be very practical here. Experiments has been done in physics on this particular topic. Okay, so let's say I'm holding a stone, and let's say this is a stone that I'm holding a stone, and I release this stone from top. I just release it. You notice that this stone will fall very faster till it hits the ground. Okay, let's say this is the stone that I release. This stone will hit the ground. This is ground. All right. This stone will fall very faster. Okay, until it hits the ground. So why does it fall faster? It's because of the action of gravity that is pulling it downward. Okay, action of gravity pulls it what? Downward. So there is a gravitational force that pulls it what? Downward, and that's why it falls faster. Also look at another example. I'm also holding the same stone, and this same stone I throw it upward. All right, when I throw this stone upward with the action of gravity, the stone also, like I explained, the stone moves. This is the ground level. All right, this is the horizontal plane. So let's say this is the horizontal plane where the stone was thrown from. So this stone now moves faster, then it becomes slower. It reached a point, then it started falling again. Okay, so this is the stationary stage. Stationary stage. So here we say it is what? Lower, and this is what? Higher. Okay, so here should also be what? Higher, and that's what I explained to you. Okay, so that's what the force of gravity does. So a free fall due to gravity is when this is falling from a height down. So because a force of gravity will help you to fall down. But there is an instance I'm going to give you when you are using feather. Feather, the weight of feather and that of stone are not same. So let's say we have feather and I'm holding a feather just the way I held the stone. Let's say this is a feather. Please do not mind my diagram. Okay, let's say this is a feather and I'm holding a feather. So I'm holding a feather. I left this feather to fall just the way I release the stone from a height. Okay, so you notice that this feather will not fall as faster as what that of the stone. All right, not as fast as that of the stone. All right, the speed was not as fast as that of what the stone when I released it. Okay, so the stone fell very fast. So you may ask yourself, what is it? What is the reason why if I release a stone from the height and it falls very faster and hits the ground, but when I release a feather from a height, it does not fall faster as that of the stone to the ground. All right. But why? You now ask yourself, but they said that action of gravity acts on whatever object that you are releasing from a height. Why is it that that of feather is different from the stone? So the reason is because of what we call air resistance. Air resistance. So air resistance acts on this feather and not on the stone. Why? Because the weight of the stone overpowers that of air. All right, that's why it does not control the stone and it falls down. But when you consider feather is very light, that when you throw it, air can control it. All right, so it will be controlling it. It will be like this until it gets to the ground, and that's why we say with the air resistance, this feather will not be able to hit the ground at the same time as that of the stone. But now experiment was done, and we discovered that when stone and feather are put in a vacuum, the vacuum should be a closed vacuum where there's no air resistance. The behavior of the stone and that of the feather are the same, meaning that behavior, let me use this, behavior of stone is equal to what? Behavior of feather. All right, under a closed vacuum. Sorry, in a closed vacuum. The behavior of a stone is equal to behavior of a feather. A behavior of a stone is equal to the behavior of what? A feather in a what? Closed vacuum. So it means that if we bring a closed vacuum, let's say this is a vacuum now, all right, and this vacuum is closed, it must be closed so that there will not be any air resistance into the vacuum. So then a stone is released, this is a stone here, and we have our feather at this place. All right, we have our feather here. So now you say, let's say A is the stone and B is the feather. It means that when this stone and the feather are all both released at the same time, both of them will fall to the bottom of what? The vacuum at the same time. So the rate here, let's say we're using 5 minutes. So this should also be what? 5 minutes. All right. We say that A is equal to what? B in terms of what? Behavior. All right. So that's how we discover that without air resistance, all right, without air resistance, the stone and that of what? Feather can all both fall or have the same speed when they are both released from a height. And this is the height where they were released from, and both of them fell to the ground of what? This vacuum at the same time. So that's what that limits the feather from falling the same time, even with the action of gravity on it. All right. So we're going to look at the projectile motion fully, where we discuss the horizontal and the vertical projections. So the next topic we're going to look at is projectile motion. Please make sure you check this topic, because that is where what we're going to discuss. Projectile what? Motion. We have vertical and horizontal projection. So that is going to be the next topic from this motion under gravity. So we're going to discuss the time. We also discuss maximum height and so many other things with examples that you're going to see there. So thank you very much. That's the end of today's class.